Okay, ladies and gentlemen, good morning or afternoon. We're going to go through the second last thing on our content today. Well, third last, shall we say. What we're going to do is we're going to look at what happens if we put a power to a complex number. Effectively, guys, we already know that if you are multiplying a complex number, you multiply the moduli and you add the arguments. So with this logic in mind, if you're multiplying a complex number by itself a specific number of times, you multiply those moduli the same amount of times. So you put it to the power of that integer. With the argument, however, you would just continuously add them together. So to make it easier, multiply the argument by said integer. And the theorem for it, you can laugh at me as much as you want, it is called Moivre's Theorem. Don't believe me? Ask Mr. Geisel, I'm sure he'll back me up on that one. What I want you to do, guys, is I want you to pause this and write everything in blue down. You can clearly see that if we're multiplying a complex number, putting it to a power of 2 or 3, we can see what's happening to our moduli and arguments. If we, however, put it to a negative power, what we have to do is put it as 1 over the positive version of that integer times the positive integer of the argument. So let's jump into our first example. If our complex number is 3 cis pi, determine z to the power form in Cartesian form. Now you can already see, guys, right here, I've made an error. I don't have any red pens around for me to fix it. Our complex number is z cis pi. So make sure you write this down, not 2, write down pi. If it's z to the power of 4, that means it'll be 3 to the power of 4 cis 4 pi, which simplifies to 81 cis 4 pi. We then bring it down into its Cartesian form. R cos of angle plus I R sine of angle. 81 cos 4 pi plus I 81 sine 4 pi. The absolute of cos 4 pi is 1 because it's 2 complete revolutions. The absolute of sine 4 pi is 0. So this gives us 81 times 1 plus 81 times 0 I. 0 I cancels out, leaving nothing but 81. For our next one here, and this one I mucked up a little bit again with the writing of it. If our complex number is 4 cis, this is meant to be pi on 6. 30 degrees is the degree version. Pi on 6 is the radian. So please write that as pi on 6. Determine the inverse of z. So we follow the rule. 4 to the negative 1, 4 to the power of negative 1, cis, negative pi on 6. That becomes 1 on 4 cis, negative pi on 6. Thankfully, we can bring this down a little bit more. We can write it as R cos of angle plus IR sine of angle. Substitute our values in. The absolute of cos pi on 6 is root 3 on 2, as you can see here. The absolute of sine negative pi on 6 is negative 1/2. Multiply them together and simplify its form because they both share the highest common multiple of negative 1/4, giving us negative 1/4 bracket root 3 on 2 minus 1/2 I. For our third example, this is where we get the more complex stuff going through. Oops, sorry about that. If z equals 2 plus 2i, express z to the power of 6 in Cartesian form. So first up, we need to actually put it in polar form. We find the modulus which guess what, guys? 2 root 2. Oh, and by the way, guys, if you actually draw up this triangle 2 and 2 with a modulus of 2 root 2, it is similar to 1, 1 root 2, one of our exact triangles, which means the angles are the same, which means the angle is pi on 4. Perfect. Therefore, the polar form of this complex number, r cis of angle, is 2 root 2 cis pi on 4. Now, we put it to the power of 6. RK cis KO, K angle. 2 root 2 to the power of 6 becomes 512. 6 times pi on 4 simplifies into 3 pi on 2. We then convert it back into Cartesian form. 512 cos 3 pi on 2 plus I, 512 sine 3 pi on 2. Cos 3 pi on 2 is equal to 0. Sine 3 pi on 2 is equal to negative 1. Multiply them out. 0 take 512i, take 5, meaning the last part is negative 512i. For example 4, simplify the following. We've got 2 different components. Sorry, I'm only laughing because my little man can hear me talking. I think he's going to burst in any second now. Hi, William. I'll pause the video and get you on the next one.